Winds. As we go through the following information, keep these questions in mind. What is wind? What causes wind to blow? Which direction does it blow? How is wind measured? And what are the different types of wind? Wind is the horizontal movement of air from an area of high pressure to an area of low pressure. All winds are caused by differences in air pressure. Most differences in air pressure are due to the unequal heating of the atmosphere. And this is because of specific heat. Water and land have different specific heats, and they heat and cool differently. Water has a higher specific heat than sand, so it heats much slower. Cool, dense air sinks and has higher air pressure. Warmer, less dense air rises and has lower pressure.
Wind is moving air. It is created by differences in air pressure that arise from the uneven heating of the earth by the sun. Warm, less dense air rises at the equator and creates low pressure areas. At the poles, the air is cold and dense. It sinks and creates high pressure areas. Because surface winds move from high pressure regions to low pressure regions, wind generally moves from the poles to the equator.
Why air moves? Air rises at the equator and sinks at the poles. As the cold air sinks, it creates areas of high pressure around the poles. This cold polar air then flows toward the equator. Pressure belts are found every 30 degrees, and they have convection cells, which are separated by these pressure belts, which are bands of high and low pressure. So every 30 degrees latitude, the wind circulates. The air is constantly circulating within this 30-degree area, and each area has a name, depending on which direction the wind is blowing and where it's at. So at the poles, the winds are always blowing from the east, and so we call that area the convection cell of polar easterly winds. South of that, we have the westerlies, because the wind tends to be blowing from the west. Below that, we have some easterly trade winds. The wind is blowing from the east. Trade winds here, blowing from the east. Global winds. Global winds are caused by global convection currents. They blow steadily from specific directions over great distances. The high-pressure, cool air at the poles tries to fill in the low-pressure areas at the equator. This causes the global winds. This is why the weather systems tend to always come from west to east in Georgia. We live in this area where the westerly winds prevail. Pressure cells. The Earth is encircled by several broad prevailing wind belts. The three primary circulation cells are known as the Hadley cell, the Ferrel cell, and the polar cell, and they're characterized based on the direction of the wind circulation. North and south of the equator, there is a Hadley cell on either side, and the wind is constantly flowing toward the equator. It heats up, becomes less dense, and rises. As it cools, it becomes more dense, and then it circulates back toward the ground. The Ferrel cell is moving in the same direction, and as is the polar cell, north and south. We're familiar with the Coriolis effect. This is the apparent curving of the path of currents, such as wind, due to the Earth's rotation. This causes winds to curve to the right in the northern hemisphere and to the opposite direction in the southern hemisphere. And you'll remember that the wind wants to blow straight, but because of the curve, the rotation of the Earth, it makes what looks like a curved path on the surface of the planet. We saw this with ocean currents, and it does the same exact thing with wind currents. And here the black lines represent the direction that the wind would blow if the Earth were not rotating, and the purple lines show the Coriolis effect on the winds. Winds are measured in different ways. Winds are described by their direction and speed. A wind vane determines wind direction. The name of a wind is the direction it is coming from, so a north wind is from the north and it is headed to the south. And the wind vane always points into the wind. Wind hits the paddles and it forces it to blow directly into the wind so that the arrow is pointing where the direction of the wind is coming from, and the tail shows you where it's going. Wind speed is measured with an anemometer, and that's what this is right here. It has little cups on it that catch the wind, and it makes this top part spin around, and it measures how fast the wind is blowing. This doesn't tell us anything about wind direction, and a wind vane doesn't tell us anything about speed. Wind chill is something we need to know about. Wind blowing over your skin removes body heat from the surface of your skin. The increased cooling that a wind can cause is called the wind chill factor. And so on a certain day, we could have a temperature on the thermometer of 0 degrees Fahrenheit, but if the wind were blowing 5 miles per hour, it would feel like it was minus 11 degrees Fahrenheit. And so the wind can really make it feel a lot colder. Local winds are winds that blow over short distances. They're caused by unequal heating of the Earth's surface within a small area. This creates local convection currents. So these are much smaller than the global convection currents we saw earlier. These form only when no winds are blowing from far away. Sea breeze. In the morning, the sand heats up much faster than the water, so the air above the sand is hotter. And this is because of the high specific heat of water and the low specific heat of land. Hotter air is less dense, so it rises. The cooler air over the ocean will push in to cause the hot air to rise up. So in the morning, the wind is in your face as you stand in the ocean. Stand with your face to the ocean. So in step number 1, the warm air rises over the land during the day because the sand is heating the air, causing a convection current. The sea breeze moves inland to take the place of the rising air. The cumulus clouds develop in the sky and they move toward the sea. They accumulate condensation here and form clouds. The upper level return. Cool air aloft sinks over the water because it's more dense, and then it blows back in towards land as a sea breeze. So land breezes usually happen at night. At night, the sand cools very quickly, while the ocean temperature changes just a little. So warm air over the ocean rises. It's pushed up by the cooler air over the beach. So the wind will hit your back as you look out over the ocean at night because the water is warmer than the land because it has a higher specific heat. So the warm air rises because it's less dense and the circulation happens in this direction. The wind is a land breeze at night. The wind is coming from the land. So cool air sinks over the land because it's more dense. The land breeze moves out over the water to take the place of the warm air rising over the water. The relatively warmer water heats air, which then rises, and the upper level return to sea breeze. Cool air over the land sinks, and the circulation of a land breeze.
Local winds are winds that are influenced by the geography of an area. For example, during the day the land heats up faster than the water. Warm air rises above the land, creating an area of low pressure. Cooler air over the water forms a high-pressure area. Because air moves from high-pressure areas to low-pressure areas, this situation causes a sea breeze to blow in from the water. At night, the land cools faster than the water. A high-pressure area forms over the land and a low-pressure area forms over the water. Air moves toward the water, producing a land breeze. Mountain and valley breezes are also examples of local winds caused by an area's geography. During the day, the sun heats the valley and warm air rises, moving upslope and creating a valley breeze. At night, the mountains cool faster than the valley. Cold air sinks from the mountains, moves downslope, and produces a mountain breeze.